Hey y'all, Data Guy here. And today I have a video for you where I'm going to run through in a single Spark script how you can interact with almost any single type of data using Spark SQL queries. So going to be things like Parquet files, XMLs, JSON, CSV, JDBC databases, every single type of kind of non-standard data. We're going to go through and I am going to show you how you can interact with it with Spark. So it should be a pretty comprehensive video for just learning how to interact with different types of data within Spark. And I'm just going to do it in one script because why not? Let's have fun with it. So if you're looking at how to run Spark locally as well, check out my previous videos on that. And if you like this Spark content, please like and subscribe. It helps me immensely. But without further ado, let's get started. So to get started, what I'm going to do is just create a new Spark script. So we're just going to call this interacting with data.hi. And then we can get started. So the first thing we're going to do, as we do with all of our Spark sessions or our Spark scripts, is import our Spark session. So we can initialize a Spark session. And we're also going to import PySpark SQL row so that we can interact with the different row functions that are available through PySpark. And such as basically querying the data. And so the first one I want to go through is just how to just do some basic interactions with Spark. So this, I'm just going to kind of think of this as a generic data interaction. And this is just kind of going to form the ground basis for how you interact with data with Spark. And in this occasion, going to be with Parquet files, but just I want you to kind of think of the high level concepts here of the basic operations and then how they're going to translate into all the other different types of data. So the first thing we're going to do is use the spark.load function. So using spark.read.load, we have an example source main users Parquet. And this is just loading a sample Parquet file included with Spark. Then a select statement. So a select statement here, what we can do is say, so one thing you can't do in Spark is modify data frames. So if you want to create a new data frame, you are going to select some features, in case it's the name and favorite color from this Parquet file, from the data frame created from that Parquet file. And then we're going to save that as a new Parquet file called names and favorite color Parquet. Then we also have the option to partition data files. So here we're going to load a Parquet file again. So just using the same kind of example Parquet file, we can then say, hey, let's partition it by instead by favorite color, format Parquet, and then name parts by color. And in this case, the data will be organized by the favorite color column. So each block of data will be just, all the favorite colors will be put together and then save that result as a Parquet file. And partitioning helps in organizing data based on column values, which can then help improve query performance on larger data sets. Then the next thing we're going to do is, let's say, again, read this blank Parquet file. And then next thing we're going to do is actually write a new bucket. So here, this data, if we use users.write partition by favorite color, bucket by 42 name, and save as a new table users partition bucketed, what's going to happen here is this step's going to partition the data by favorite color, bucket the data, so partitions data within each partition by name using 42 buckets. So within each bucket of favorite color, it's then going to sort by name and bucket all entries with the same name and 42 different buckets. And this process is used for saving data in an even more organized manner, which is especially beneficial for, again, large scale data processing by distributing the data into a large fixed number of files or buckets. So it's going to actually save each bucket of data as a different table. So now you have user partitioned and bucketed data, which is kind of that second level of drilling down into it. Then we also have some manual load options. So let's say we want to load in a JSON file. So here, if we use load JSON, again, just using some of the example data included with Spark, we can explicitly specify the format and then manually set the data source format. And then here, what we'll do is this loaded data frame is then filtered to select the name and age columns and then save it as a Parquet file. So similarly to what happened up here, except instead of name and favorite color, it's name and ages and a different way of defining it, where we're explicitly saying the format we want to save it as. So just kind of a different way of doing a similar action. Then we also, so here what we're going to do is kind of just another option to load. So here with we're just loading a data frame using, again, that spark.read.load function. Again, just from the Spark example data sets, but just showing you how you can specify the format, the separation for comma separated files, first schema equals true, header equals true, and just some of the kind of different configuration options you have available on the load. Obviously, check the documentation for the full one, but it is pretty robust. Then next you have your option for manually saving. So here we're just reading user's data frame and then immediately writing it with ORC format. So ORC Bloom, key threshold, encoding direct, and we're saving it as a .org file. And if you don't know what an org file is, don't worry. I didn't either, so look it up. It's an optimized row, column, or file format from Apache org. So great name for a project, but haven't heard of it really ever in the wild. So interesting. Next, we have another just kind of different manual save options, where here we're just going to customize our Parquet file a little bit just to show you kind of the flexibility of the manual save option. So here, just reading a Parquet and then immediately writing it back. User's data frame right, and here we're setting the favorite color to whatever the color code is for 1,000,000, enabling a dictionary checksum if we want to do a checksum operation, and then saving it again just as a Parquet file. Then we have Spark reading JSON and then writing it by bucket. So here you can actually save as different tables or different buckets within a table. So here, reading a JSON file, then data frame, so write sorting. So instead of sorting it like we did up here and then writing it, this time we are writing it just using .write, bucket by, .sort by, .save tab as. So it's all just done in one function. Kind of just like different options on how you prefer to write your code there. Then, if you want to write some SQL to just create a data frame on a Parquet file, what you can do is write your spark.sql query, select star from Parquet, and then here we're injecting the Parquet file here, so the path, so it knows where to go look for that Parquet file, and then we'll select all the contents of that and save it as a data frame. So really, nice way to interact with SQL with Parquet or CSV files and immediately bring that into kind of the data frame format for some downstream manipulation. Then we can also just do some Spark SQL drop table if it exists. So this is just some cleanup operations, but showing you different ways that you can just drop tables from Spark by just writing, again, Spark SQL statements. Next, we have some Parquet specific examples. So here we're going to create a new definition, and so Parquet example Spark session. And here, if we want to, let's say, read a JSON in, so here we're going to read from this people JSON, again, just one of the default ones, and then we can actually save a data frame as a Parquet file. So you don't need to necessarily convert directly from JSON into Parquet. You just bring in the JSON file as a data frame, and then you can write that data frame directly into Parquet using write.parquet. And this will maintain the schema information as well. Then we also have Parquet file equals spark.read Parquet. So here we're reading the Parquet file we just created using spark.read Parquet, and then it's also going to be a data frame, the same data frame that we just saved there. You can also be used to create a temporary view here. So if I wanted to use a Parquet file to create or replace temp view, so just create a new temporary view called Parquet file. And then teenagers, we can say is Spark, or teenager equals spark.sql select name from Parquet file where age is 13 and age is greater than 19. So just using SQL on that Parquet file view that we just created. And then what we can do is just show the teenagers that are in there. So here we just have a simple example here, name, Justin, example, basic Parquet examples. So really simple stuff here. Now next, I'm going to show you how you can actually merge two different Parquet files. So here, we're going to define a Parquet schema merging example. So spark equals done. And then we are going to create a simple data frame and just store it in the partition database, so just using the Spark context. Then we're going to create a data frame with Spark create data frame and just use some basic math to just create a simple data frame of some numbers, then save it as a Parquet file in this particular table. So here, data equals test table, key equals 1. Then we're going to create another data frame in a separate directory and add a new column and drop an existing column. So here, just a slightly different data frame, different range. So see 6 to 11 versus 1 to 6. And this is just creating dummy numbers. And then we're going to write that into a separate partition using this key. So test table key 1 will save this data frame to the partition 1 of test table, and then partition or data frame 2, the cube's data frame, will be saved to partition 2 of the same table. Then we're going to read the same table and print the schema. So here, merge data frame equals spark.read option, merge schema, true.parquet test table. So just reading from both of those partition files as a single parquet, as a single table. And then the final schema will consist of something like this. Double long, nullable equals true, single, triple, long, and these are just, again, the different rows of single, double, and triple, just random numbers. Next, so that's how you can bring in two data frames, partition them, and then also have them presented as a single view. So instead of needing to have data stored in different tables, querying separate tables, even though you do still want to organize them separately, you can preserve that with different partitions by using kind of this method here, and then just query them all in a single command. Next, we have our JSON data set example. So this is going to show you some different ways for interacting with JSON data sets. So here, again, setting just a Spark context session, and then we'll go down to create a path to our JSON file. Again, just using one of the Spark kind of typical ones. Set our path, and let's see why this is not running every time I do it. And then we're just going to read this JSON from this particular path. Next, our inferred schema. So if we want to actually print the schema, we can run the people's data frame print schema. So even though you're reading it from a JSON file, which doesn't necessarily have a schema, when you're converting it from JSON using the Spark read JSON, it's automatically giving it a schema. In this case, assigning columns to the name or age and string, with name being a long integer and a string or name being a string. Now, again, we can create a temporary view with the data frame. So people df, create or replace temporary view, people. And then similarly, we can run a Spark SQL select statement where we can get a teenagers data frame and just go to teenagers, sparks .SQL select, and then do a .show method as well. Alternatively, and something unique for a data set object, for a data frame for JSON object, is that you can create a data frame that is represented by an RDDD string, which stores one JSON object per string. So here, what that will look like is, let's say I have a name and an address, and the address actually contains subvariables. I can contain the contents of that address in a single string, in a single JSON object, which will just allow better, more efficient storing, because that way I can just store two columns, name and address, and then each of those entrants in the address column have that city and state, because that's, instead of needing to have separate city and state columns broken out. And so you can see that kind of happening there. And then when this .show command is run, then you'll see something like this. So here, address name, where you see you have Columbus, Ohio under that yin address, even though they, in the JSON, original JSON file, they do have city and state as their JSON names. So that's JSON. Next, we have our CSV dataset example. So here, we're going to find a new Spark function here, sc equals Spark context again. Then what we're going to do is set the path. So here, path equals example csv.main or peoples.csv, and then we'll read that CSV again, just using the spark.read, and then we can do dataframe.show, and we can just look at our data real quick here, spark.show, and then just some basic information around these people, Jorge and Bob. Then what we can do is, let's say we want to read a CSV with a different delimiter. So instead of it being the default, which is comma separate value, surprise, surprise, we can also do something like, hey, what if they're using a semicolon to delineate entrance? So here you can use spark.read option, delimiter, and then this .csv, the semicolon, and then you can read CSV files like this one that before you notice you had that semicolon between each entry. And actually, let me just bring that back up. So here, see you have that semicolon between entrance versus down here. You do not. So great way to deal with non-standard data storage formats. Then let's say you have a header as well. So read a CSV with a delimiter and a header. So here, instead of having the name, age, and job as just another entrance to each column, you have our option to define a header, delimiter, and header is true, CSV, and then same path. And then now we have our nice, clean little data set instead of those ugly C0 column headers, which you saw before. So we can delete this. And you can also use options as well. So if instead of having it kind of clunkily .option, what you would probably want to do is .read, .options, and then you can have each option separated by a comma there. Then you can also write a CSV file just to a folder. So here we have output. It's just a folder that has CSV files in it already. You can actually read all files within a folder. So if you want to folder path equals main resources, read CSV, and then folder path, you actually can see, so you'll see some if you run this command on just your default Spark environment, you'll actually see some crazy values. So it's not actually set up to read all the CSVs properly because there's other data sources in it that aren't CSVs. But if you only have CSVs in a folder, then it will show them all at once. And next we have our text data sets. So maybe you're working with just plain .text files, especially for natural language processing. This can be a common way that you're ingesting data. Again, we're going to set the Spark context, and then we are going to set a path to our text file. And then we are going to just read and show you the path, so just so you can see the data real quick, or read the text from the path. So here, Spark.read, we have our Michael, Andy, and Justin. And then we can use our line separate option to define the line separator. So if you want to have different line separators for your values, if you want to make sure, maybe that you're using your text file is using something other than just a space or entry, like a -r, a -n, -new line, then maybe we want to consider the line separation might be this column or this comma. So here, this is actually saying that Michael, new line, 29, then Andy. It just makes a really ugly data set. So that's why it's kind of confusing here, because obviously the line separation shouldn't be by each comma, because it should instead be by each new line. And you can see that reflected by that -n there, which is that -new line. Then we can also use the whole text option to read each input file as a single row. So this shows each row, each line within that document as a different value. Here, this will show every single value within a single row there. And then you can also write an output file to a CSV. So here, if I write to CSV, I can just to write df1.write CSV output. You can also specify a compression. So a lot of times, especially if you're doing large text formats, probably going to want to compress it because it's just a lot of data. You can use define compression method there. Then we also can define a JDBC dataset example. So next, we are going to show you how to do this with JDBC specifically. So JDBC loading and saving can either be achieved via the Spark.load and save or by some specific JDBC methods. So here we're going to show you kind of what it looks like to actually interact with the database. So JDBC df equals spark.read format JDBC, URL is just a Postgres server, schema, just generic functions here, but just filling out all your different connection details and then using the .load function. And then we can also show you how to use spark.read using a kind of different method of connecting. So here, if you wanted to use the JDBC method, you pass spark.read and then .jdbc and enter your details in via that JDBC connector. Just make sure you have your JDBC connector installed. Although I believe now Spark actually might come with it pre-installed. Then we have df3 here, which is again a different way of interacting with it, where we're defining a custom schema, so defining the data frame column types on read. So now if we interact with this, we know that this is a decimal, this is a string. For the name is a string, ID is a decimal, and then we also have the option to write to a JDB source. Again here, just the two methods, one using the .save with your .options here saved, or you can use the .write.jdbc method as well here. You also have this jdbc.write if you want to define and create column data types on using that JDBC method as well here. So you can see here, name, comments, varchar, creating those column types using that JDBC write method. Now we have, we're almost done here, we have XML left. So here for an XML example, we're going to create one more XML function here. Then Spark session equals none. And then we're going to find the path just to an example XML file. And then we will read in from that path, just a data frame. So reading in option, row tag, person, format XML. So just giving the proper row tags. This path can either be an XML file, a single one, or multiple. And also you need to make sure that you'll need to have primitive types, so like int, type, or string and product types, case classes encoders are supported when importing this via when creating a data set. So just make sure you kind of have those primitives are the ones you're using. You can also print PeopleDF infers a print schema, and this will show you kind of how it infers the schema. So here it inferred name and age from the reading in of the XML file. And then we also have, and that's how, because the new row tag was person. You could also create a temporary view here, PeopleDF.create or replace temp. So just as we created with the other data frame methods. And then we can again use that teenager names data frame query using Spark to query this XML file and then run a .show. And alternatively, and this is where the XML specific stuff gets into play, you can actually create a data frame for an XML data set that is represented by a data set, like a string name. So here we have XML strings, Langley Yu as a developer who is of age 28, and their person start, person end. And then what I can do is Spark context, so tell it to, this is similarly to how, with JSON, we could read a object that contains multiple pieces of information as a single object. So now spark.read, we're going to read this from the Spark file we just created, or this XML file we just created, and then show other people. And what this will do is create a data frame where a single row contains all those different sets of information. Option. There we go. Perfect. And then what that'll look like is this. We have age, job, name, example of showing an XML data set being visualized. And then just to create all these, so just to define them all in your Spark sessions, these will work at the end of the day. Define Spark equals Spark session, have all of our different function file names, and you're off to the races. So that is every single way you can interact with data sets and data frames, or for every single different type of data set and data frame. I'm sure I missed some different ways of interacting because there's a million out there, but I hope this kind of serves as a comprehensive guide for showing you how you can interact with your data with Spark. Hope you enjoyed this as much as I enjoyed making it. Have a good one. Data Guy out.